Welcome to the hands-on section for memory functions in the string.h library. And the first example we look at is use of the MEM Copy function. In this one, we define a character array S1 of size 17 characters and another character array of string S2 and initialize it to this string over here, copy this string. And MEM Copy copies the contents from S2 into S1 up to 17 characters. And then we print out the contents of string S1. Going to run this. There's actually nothing to step through here. And you can see that copy this string makes it from S2 into the contents of string S1. Next example is the memory function MEM Move. And in this one we have a character array or string containing initialized called X, named X, initialized to home sweet home. And we print out the contents of X before we call MEM Move, and then we print out the contents. The contents of X again after we call MEM Move. And in MEM Move, what we do is the destination is array X, and the contents are starting from character number 5, element number 5 of array X, and we copy 10 characters. We move 10 characters. Let me run that. So, meaning from we move sweet home from here to the start of the string. And what that'll do is it will replace these 10 characters with sweet home. So we end up with sweet home home. There you go. Remember, a lot of what these memory functions that we looked at do if you're working specifically with strings, can be performed with other string-specific functions. Whatever we're doing over here can be these operations of copying contents from one part of memory into another, moving contents from one part to another, can be performed for any underlying data structure. We just happen to be using character arrays over here because character arrays can be printed out and seen because can be printed out and seen easily byte by byte because each character is stored in 1 byte. Otherwise, all these operations are performed on units of bytes, not on integers, characters, or anything like that. Okay. This is the MEM Compare function for comparing contents in memory up to a specified number of bytes. So we have 2 character arrays, 2 strings, S1 and S2. They both have the same beginning, A, B, C, D, but then the first array goes on with E, F, G, while the second string, S2, ends with X, Y, Z, but they both have the same length. So we print out the 2 strings, S1 and S2, and then we call MEM Compare function for S1 and S2 up to the first 4 bytes. And we already know that those first 4 bytes are mapped to the first 4 characters in that string, and they are the same in both strings S1 and S2. But then we extend the comparison for the second call to MEM Compare. We extend that to all 7 bytes, and that's when we'll of course have differences. And remember, when the comparison, when the 2 sets of bytes, when they match, the the return value will be a 0. If they don't match, the return value will be a +1 or -1. Run that, and there you go. So first time we have 0, the second time we have -1, the third time we call memcomp, we get a +1. And similar to the string character search function, we have a character search, a byte search function in a sense, for anywhere else in memory. So in this case, we're going to search for the character R in this particular string. This is a string, and we find it. I'm sorry, we find that. We find R in the word string over here, and this returns a pointer to that location of the string. And if you print out, cast that as a character pointer, you can print that out as a string, which is what we're doing over here. We're printing it out as a string, the return value from mem character search. And we're printing out the remainder of the string from that then onwards, which is the word ri, which is the characters ring, and interestingly makes the word ring. And there you go. So the remainder of s after character r is found is ring. Not sure what's going on over here with this. With the display of this letter as RB or something. Must be some hidden, could be some hidden character. And run that once more, see if that fixed it. No. All right. And that gets us to the last function, MemSet, which copies a specified byte, in this case this character B, for a specified number of times, specified in the third argument, 7 times in this case, into from the start of string 1. It should be string 1, not string L. Fix that. Would have run anyway, but just keep it. All right. So this call to MemSet will copy the character B into the first 7 bytes of string 1. And string 1 is initialized to be a 15-character string containing all capital B's. We're putting in a lowercase b into the first 7 bytes. We run that, and there you go. So string 1 after memset turns out to be 7 lowercase b's followed by 7 uppercase b's. Remember, the last character over here is the null character. And that's all about memory functions.